All right, welcome guys. In this video, we're going to finally be moving into section 8.1. That's similarity in right triangles. So we're kind of bridging the gap between chapter 7, which is similarity in triangles, and chapter 8, which is all about right triangles. All right, so as we jump right into this, let's start off just by understanding what the geometric mean is. So for a number, which we will call x, that number is the geometric mean of two other numbers, a and b, if x is equal to the square root of a times b. So let's say, for example, that we are given a problem where we need to find the geometric mean of two numbers. Let's say that those two numbers are 4 and 9. All right, so we are going to find the geometric mean of 4 and 9. All right, we are just going to say that that geometric mean, again, which we will call x, is equal to the square root of 4 times 9. 4 times 9 gives us that 36, and the square root of 36 is 6. So boom, there's our geometric mean of 4 and 9. Obviously, you can see that if you struggle with radicals, this is going to be a challenging section for you. So that's why we covered those radicals before we jumped into section 8.1. All right, so the next thing that we're going to look at is, well, where do these geometric means appear in right triangles? At this point, if you guys would like, you can definitely put your pencils down. We are going to just prove why some things are geometric means of others. All right, you don't need to copy that down. When you do need to pick up your pencil again and copy stuff down, I will let you know. All right, so here, I've got one large right triangle. I've got this right triangle ABC with its right angle at A. At that point, I then drew an altitude from A to segment BC. Remember that by definition, an altitude goes from the vertex of a triangle to perpendicular to the opposite side. So we're from the vertex A, perpendicular to BC, creating a right angle there as AD meets BC. All right, from that, we can then determine three similar triangles. If you want to pause the video and figure out what those three similar triangles are, great, you could go ahead and do that. Those three similar triangles are right here. It's ABC is similar to DBA is similar to DAC. And those are all based off of angle-angle similarity. Then if we know that two triangles are similar, we know that their sides are in proportion, so we can write proportions that we know to be true. All right, so on this next slide, I wrote a couple of proportions that we know have to be true based on this similarity right here, the fact that ABC is similar to DBA, which is similar to DAC. All right, so what we might notice here, we get AD over BD equals DC over AD. We see that AD appears twice. Well, if we were to cross multiply, we would get AD squared equals BD times DC. And then if we were to take the square root of each side, we would get AD is equal to the square root of BD times DC. Well, what does this remind us of? Let's just check back 2 slides and look at how do we find the geometric mean? We're taking the square root of the product of two numbers. So here, AD is actually the geometric mean of BD and DC. We also can find that AB is the geometric mean of BC and BD. And lastly, we will find that AC is the geometric mean of BC and DC. All right, at this point, you guys can pick your pencils back up. We're gonna go ahead and take a look at a right triangle on the next page. All right, so here we've got this right triangle. I have not labeled any of the points on here, but I have labeled each side as a length. All right, so we've got A, B, C, X, Y, and Z. And this C is referring to the entire side length of that large hypotenuse. All right, so here we're just gonna write out what is the geometric mean of what. So the first one we are going to see is that y, this altitude. So the altitude is the geomean or the geometric mean of the two parts of the hypotenuse that it splits up. So it is the geometric mean of x and z. All right, y is the geometric mean of x and z. Our second one is that this leg right here, this leg B, so B is the geometric mean, geomean of x and c. So this portion of the large hypotenuse and the whole hypotenuse. So of x and c. And then our last one is over here with A. All right, so our third one is that A is the geometric mean of, again, this portion of the hypotenuse and the whole hypotenuse. So A is the geometric mean of Z and C. All right, so for any one problem, you're gonna need to be able to take this diagram. If you want, take a picture or a screenshot of this if you can. You can definitely use this for the homework. On the quiz, I will give you this same exact diagram. This same exact diagram telling you A is the geometric mean of Z and C. You just need to know, what does that mean? How can I use it in order to find the missing side lengths? All right, so take this triangle. On the homework, some of the triangles might be rotated a little bit depending on where they drew the altitude and where the right angle is. That's okay. You can use this diagram. I highly recommend it so you're not spending all your time memorizing small little facts.